All right, today we're going to be talking about combinations and permutations. Combinations is a way of counting the number of ways to select. Select is an important word there. Select R objects, R being a variable there, from N objects. So just selecting a group of R objects from N objects. In parentheses here, I'm going to write not labeled. I'll talk about what labeled means. You may have heard like where order matters, order doesn't matter. Labeling is a different way of thinking about that. So I'll kind of talk about both sides of the argument. For those of you that understand what order matters, order doesn't matter means, just stick with that one. If that's been confusing to you, or if you've ever heard that and it's confusing to you, then the labeling may make things a little bit clearer. So the things we're selecting are not labeled, right? So it's just a group of objects that we're selecting from a larger group of objects. We write this as NCR, and you'll have a button that kind of looks like that on your calculator as well. And the formula for this calculation is n factorial over r factorial n minus r factorial. All right, we have a formula for computing this NCR. We're going to read this as n choose r, meaning there are n objects, and I'm going to choose r of them. Right? And this formula is going to count. The result of this formula is going to tell us how many ways are there to select r objects from a group of n. So an example of something like this, let's do an example real quick. How many ways can a teacher select 3 students to give extra credit to if the class has 36 students? Now, obviously, we're doing this in the combination, like right after we define combination. So we're obviously going to use a combination here. But the important things to pay attention to are that the 3 students are not receiving different things. It's just a group of 3 students that receive extra credit, right? They're going to get the same amount of extra credit. There is no, when we're selecting these 3 students, there is no first student selected, second student selected, third student selected, because they're not getting anything different, right? We're just selecting a group of 3 students. And that's what we mean by the not labeled. The 3 students are not labeled differently. The 3 students are labeled the same way, right? You select the 3 students, and those 3 students get extra credit. There are no different labels for the 3 students. So to compute this, we're going to have 36 students, and we want to choose 3 of them. So we set up 36 choose 3. We can set up our formula from above with the factorials by just filling out the n and the r with 36 and 3 respectively. So 36 factorial on top, and then r is 3, so we have 3 factorial times 36 minus 3 in the parenthesis factorial. We'll simplify what we can right now. So 36 factorial on top is fine. On the bottom, 3 factorial is already simplified. We'll simplify inside the parenthesis. That's going to give us 33 factorial. And someone asked me last time what this is on the bottom, 3 factorial, 33 factorial. That's multiplication, right? We don't usually put the multiplication sign in there, but you can if you want to, if it's going to help you remember what it is. So this is 3 factorial times 33 factorial. And if you guys remember how we simplify these, is we start writing the numerator as a falling product, and then we stop when we reach this 33 factorial. So we're going to write the numerator as 36 times 35 times 34 times 33. As soon as I see the 33, I'm not going to write the rest of the product. I'm just going to put a factorial there, and that's going to cancel with the 33 factorial that's in the denominator here, right? We have 3 factorial times 33 factorial. We can cancel these 33 factorials because everything is products. And so the simplified form here is 36 times 35 times 34 divided by 3 times 2 times 1. And you can plug that into your calculator, or you can simplify a little more if you want to. 3 times 2 is 6. I can divide the 36 by 6 and make it a 6 and make this a 1. Just to make my calculator work a little bit easier. So now in the calculator, I would just put 6 times 35 times 34. Go ahead and put that into your calculators and give me the answer in the chat. Can someone tell me what, can you put in the chat what your calculators are called? Like the TI number, if you have a TI calculator, or if you have a different one. Can you put some in the chat for me? If you have like the blue or green or pink, what's it called? Scientific calculators, I need those numbers. TI 36, I think that's a good one. What's a different one? TI 30. Sorry, I'm trying to find a way to show this online. Okay, I did find one, kind of, I think, that I can show. If you look at my shared screen, or I guess it's the calculator. Everyone see the calculator on my screen? Okay. Whoops. On the calculator, if you have a TI 30, this is kind of what it looks like. If you have a different one, you're looking for the same thing. It might be buried in some menu somewhere. If there's like a PRB button, then it might be buried in there. But on this calculator, do you see above the number 8, it says NCR? That's essentially what we did here with the 36C3. So if you have a scientific calculator, you're going to type in 36 and then hit second 8 to do the NCR, and then you type in 3, and then that'll calculate the 36, choose 3. So let me do that again for you. You type in the N first. So 36 is my N. And then you need to find the NCR on your calculator. It may be one of the, it might be above one of the buttons. It may also be in a PRB setting menu somewhere. But you're going to go select NCR wherever it is, and then you're going to type in the 3 afterwards. So the 36 is the N, and the 3 is the R, and that's going to give you the number that we came up with. So there is a short way of getting to the 7140 on the calculator. On the TI-80, let me see what the TI-80 looks like. TI-80 images. On the TI-80, I'm guessing it's in the math button. When you press math, try to look in the math menu and see if there's an NCR in there, and then let me know if you find it or don't find it. Yeah, it'll be in the math area for whether TI-84 is in the math area. It's not in the probability area. Oh, it's in math, but you have to go to the probability tab to find the NCR. Yeah, you go to math and then you go to the PRB. Essentially, you're looking for PRB, which does all of your probability stuff, which is what we're getting into now. So if there's a probability button, or in the math section, in the math button, there is a probability tab. That's where you're going to want to go for both NCR and what we're going to go over next, which is NPR. So let's move on to permutations, and then if there's any calculator stuff, we can talk about after the lesson as well. So next thing we're going to talk about is permutations. Which is similar to combinations, except now we're going to start labeling things that we select from the large group, or we're going to order things that we select from the large group. Permutations count the number of ways to select. So it's similar up to here. Select R objects from N objects. And there's no difference so far, but the last part, and label them. Or in parentheses under the label, I'm going to write order them. Like first, second, third, fourth. Or if you want to think about like ordering books on a bookshelf, that's an ordering, right? If you move the books around, that's a different ordering of those books. Right, so permutations still counts the number of ways to like group up objects, but now we're also introducing some kind of ordering to the objects, or a labeling of the objects. And here we have NPR instead of NCR, and the calculation here is n factorial over n minus r factorial. Right, again, the formula is also similar to the combination formula, except it's missing a piece in the denominator. There was like an r factorial in the denominator. That's missing from here. We read this, there's no special way to read this. We just read this as like NPR when we're reading it. You can say N permute R, I guess. P stands for permute, so you can read it that way. Also, NPR would make sense as well, excuse me. So let's do an example here. And let's see what kind of example would use a permutation instead of a combination. I'm going to write a similar example so you kind of see the subtle differences between the two examples. How many ways can a teacher select 3 students? And it's going to be to give extra credit again, but this time he's selecting 3 students to give 6, 3, and 1 points of extra credit. If extra credit to if there are 36 students. So there's a slight difference in the problem here that you're not just selecting 3 students and giving them extra credit. We're now selecting the 3 students, but one of them is getting 6 points and the other one is getting 3 points and the other one is getting 1 point, right? You can think of those as labeling the students, right? The first one of the students we select, we label with the number 6, they get 6 points. We label another student with 3, they get 3 points, and another one with 1, and they get 1 point. Or you can think about ordering the students. The first student drawn is going to get 6 points, the second student selected is going to get 3 points, and the third student selected is going to get 1 point. Either way you want to think about it, whether you're labeling or ordering the students, either way we're going to have to do this with a permutation. So this will be NPR for the calculation, which is going to be 36P3. So we want to select 3 students and we want to label them or order them at the same time. So this will be, the calculation will be 36 factorial divided by 36 minus 3 factorial. And we simplify the parentheses, 36 factorial over 33 factorial, and then we can do the following product again, 36 times 35 times 34 times 33, and we'll stop there because I know there's a 33 factorial on the bottom that we can cancel with this. So our answer is going to be 36 times 35 times 34. You can plug that into a calculator and then put in the chat what you get for that. Uh, 42. Whoa, I'm seeing different answers. Why am I seeing different answers? 42,840. The 41,580, you may want to double check your numbers. 36 times 35 times 34. Nice, good. So that's our that's how many ways you can select 3 students and give them different points of extra credit. All right. That's the 2 different ways we do counting problems. Whether you're selecting a group, whether you're just selecting a group and they're just a group of people or a group of things, and there's no inherent labeling or ordering. That's when we do combinations. Or you're selecting a group, but then also the elements in the group are labeled differently. They have different characteristics that you're assigning to them. Or you're putting them on a bookshelf, like a book's on a bookshelf, and you're ordering them first, second, third. So if we're talking about like how many ways can, let's say there's a race and there's 15 people competing in a race, how many different ways can the top 3 happen? First place, second place, third place. That there's an inherent ordering to that, right? So that would be a permutation problem. Okay, I think that's good for